Hi there, and welcome back to Weather Analysis with Mr. CB. So, in this video, we're going to mostly be talking about what can influence snowfall and snow to liquid ratios. So, first of all, let's talk about relative humidity. So, relative humidity of at least 70% within the dendritic growth zone and below it is needed for snowfall to make it to the surface. We do know that in the upper levels, we do have water that is frozen, but the fact is this snowfall going to make it to the surface or is it going to sublimate? Which that can happen if we have dry air. So there can be sublimation occurring if there's dry air or too low of relative humidity below the dendritic growth zone. Next thing that we can talk about are omega values relating to snowfall. So the omega values are associated with the upward vertical velocities, and we want to have uh, greater negative values, which are associated with the rising air, if you remember in the previous lectures, within and below the dendritic growth zone. This is going to result in a higher snow to liquid ratio. Now, another thing that's important to keep in mind is depending on which model we're looking at and the resolution of it can influence these values. Some more factors that affect the snow to liquid ratios are cloud physics. So what is the cloud have within it? Do we have supercooled droplets or ice crystals? That will affect which process that we have going on if you remember the last uh, video. And then the vertical temperature profile, we know the soundings that we can look at. Very important to use. Some people use thickness values like the 540, but that doesn't give us all that we need to know always. So this vertical temperature profile, it can change due to sublimation or evaporation, melting and freezing, thermal advection, vertical motion, convection, and solar radiation. Some more factors that can affect our snow to liquid ratio is the snowflake going through deposition or riming. If you remember, deposition is where we get ice crystals growing from water vapor, going from a gas to a solid. This is going to occur in the temperature range that's the dendritic growth zone, which is -12 to -18. We could also have riming where the ice crystals are falling from the area that's the dendritic growth zone, and it comes into contact with supercooled water below. This is at temperatures -10 to 0 degrees Celsius, and riming is more efficient at higher temperatures. Now, another thing is what is the height of the bottom of the dendritic growth zone? The higher that it is, the higher ratio that we have. So if it's around 15,000 feet, we're going to have a high ratio, 10,000 medium, 5,000 low. Also, other things that affect this snow to liquid ratio, what surface temperature do we have? What wind speed do we have? Does wind change direction as we go up? Depth of the isothermal air layer. Sorry. We have regions of the sounding that parallel the temperature lines. That would be considered an isothermal layer. What is the bottom of the snow growth region? And that's usually indicated by a purple color in the sounding. Now, ratio breakdown, the average snow to liquid ratio is 10 to 1. If it's below 10 to 1, we consider that wet snow, and above 20 to 1, it's considered dry snow. So that's actually going to be it for this video. Thank you for watching.